Alright, so yesterday we started talking about natural logs. So just keep the two straight. It's pretty obvious when they give you the logarithm. I mean, ln is quite obvious. It's not log, and that should trigger your memory. Oh yeah, this is a natural log. And again, the base is going to be e. We don't show that base. Though it's the same as that, we don't show the base e. We just write the natural log. Where does e come from? It's Euler's number. After Euler, it's an irrational transcendental number like pi. Basically, the value is 2.71828. Even though it has another 1828, it does change after that. It goes on forever. Non-repeating, non-terminating. It's irrational. Goes on forever. There's no noticeable pattern. How can you get its value? Do an infinite series of 1 over n factorial with n starting at 0, and the value would equal 2.71828, whatever the rest of the digits are there. All right, so Euler's number. Calculator use, pretty simplistic, right? If you look back at your calculator, so you're going to have somewhere on your calculator a natural log button and an e to the x button. All right, and it's going to be there somewhere on your calculator. And you got to, grab your calculators out. You need to work your calculators. Just make sure you find your E button. Should be close to your other log button. Normally they're grouped together. And if you found your regular log button, then you should be able to see where your natural log button is. All right, so same situation. What does the natural log button do? Remember, logarithms are exponents. So the log button gives you the exponent when you input the result. Gives you the exponent when you input the result. Let me get this higher for you guys. So, if you look at example number 1, and it always pays to, just for your thinking, let's go ahead and convert this to what it is. This is e to what power equals 79. Not that you need to do that, it's just for your understanding, right? It's for the, does my answer make sense? And the easiest thing to do is just think of e as 3. You're going to be a little bit bigger than your answer, because e is 2.7, right? So just think of e as 3. 3 cubed is 27. 3 to the 4th is what, 81? So maybe and 2.7 is a little bit smaller, so we're expecting something like, 4 point something. Again, depending upon the syntax of your calculator, I think most of you guys, you're going to have to punch the ln button first, then do a 7, and then do a 9. For me, I'm just punching in 79 and hitting the ln button. And was that 4.3694? 4.3694. And so go ahead and do number 2. Again, you don't have to change form. I'm just trying to show you whether to figure out if your answer makes sense. Square root of 15 is what? Or square root of 225 is 15. So it's a little less than 15. So 3 to what power is 15? And hopefully you got what? 2.6759? Right? Just punching buttons, really simplistic. Really simplistic. All right, the e to the x button gives you the result when you input the exponent. So number one would really be e to the 0.75 equals y. So again, I think most of you guys, you're going to punch your e to the x button first, your decimal button, your 7 button, your 5 button, and probably your enter button. E to the first is 2.7, so we should be lower than 2.7, right? And I got 2.1170. Just punching buttons. Pretty simplistic. All right, what do you get for number 2? Now we got e to the 7th power. Dawson, what do you got? All right, 1,107.7. Again, once we get above 1,000 or so, or even in the hundreds, you can round to one decimal place. 1,107.7. Pretty simplistic, right? Any questions on any of those? Any questions on any of those? Easy, 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 easy. Okay, what are we doing? B, right? Doing 5B, page 2. Okay, big stars around logarithms. This is the formula that is the key formula. This is definitely something you should have memorized and should remember for the rest of your life. When you come across questions on the ACT, SAT, often they'll look just like that. I mean, they'll look like that. Every once in a while, you'll also have a problem on the SAT where it'll be a common log, and it'll just be like LOG 795. Well, it's easy, right? Just hit your LOG button, 795. Or every once in a while, you'll have a question with the natural log. But you almost always have a question or two with logarithms like this. And they're really, 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 really easy. The formula is really simple. So just do the log of the result. So what's the base right now for that numerator? For this log right here that I stuck in the numerator, what's the base? 10. I made it a common log. And it simply equals the log of b. Not a base anymore. It's just a formula that works. I'll show you why on Monday when we get into log equations. Or if you want to, and this is the one I use because it saves me a letter, you can do the natural log of a over the natural log of b. Actually, I saved 2 letters. One in the numerator and one in the denominator. Really easy. The only thing you can't do is half of one, half of the other. You can't do common log a over natural log b. Don't do that. But common log a over common log b or natural log a over natural log b. That's it. Going to get the formula. All right, so a here, you're just punching it out. It's really easy. Again, I like the natural log. And you're just doing the natural log of 39 over the natural log of 5. Go ahead and punch that out and see what you get. Andrew, what do you got? 2.2763. Yep, 2.2763. How does DeMams feel about that? Does DeMams like it? Does your answer make sense? Does it? Are you sure? Does anybody actually know if your answer makes any sense? Dawson says yes. Alma says yes. Dawson, mind asking why you think yes? All right, so Dawson converted it exponent form. So he said 5 to what power equals 39, right? That's what the problem was. And 5 squared is 25. So I got to be a little bit more than 5 squared, and I'm a little bit more than 5 squared. The MAMS likes the answer. And you can do this with all of them as well. Again, if I were doing the ACT or SAT, that's only a couple seconds. That'd be worth it. If you're doing a quiz or a test with a whole bunch of logarithms, you might want to wait until you're done with the whole test. And then when you're working your way back through, checking your work, you might want to do that. But it's simple to do. All right, go ahead and do B. So easy. And you can use LOG if you're a log man. If you like woodchucks and stuff like that. What I want to know is how much wood can a woodchuck chuck if a woodchuck could chuck wood? That's what I'm curious about. Poor Betty Batter bought some butter, but said, "She, this butter's bitter." When she put it in the batter, it made all the batter bitter, so she bought some better butter to put it in the bitter batter to make the bitter batter better. It's the only thing I remember of my whole elementary school education. That's it. Does the MAMS like your answer this time? Shane, what do you got? 2.8105 is what I got. And again, if you were to convert this thing, this would be 11 to what power equals 845. 11s we're not as good with, but 11 squared is 121. And then 11 cubed would be 121. Just do times 10 instead of 11. So that's 1,200. So it's got to be less than 11 cubed. And so the MAMS likes the answer. Yes, Dawson. Yeah. Yes, you could punch it back into your calculator. You could. But again, you still have to know this. I mean, you got to convert it to this. You got to be thinking that that's what it is. Yes. You can stick it right back in your calculator if you don't want to do the mental stuff. If you are mental, then that's fine. All right. So without further ado, do C. Solve C. Exponential equation. I don't even have an answer for this one. Danielle, what do you think? Anybody agree? All right. So a couple different ways you can approach this problem. If you change it into logarithm form, right, and therefore make it base 7, result 350, isn't this just like the problems we've done a second ago? Sure it is. And therefore then you can do log or save a letter. And this is indeed 3.0104. Right? So I converted it to log form and then used the change of base formula. All right, let me show you algebraically how to do it. And you should learn this. We're going to talk more about this on Monday. If you were to solve this algebraically, I'm going to take, let's see, it doesn't really matter. I'm going to do the natural. Let me do it this way. I'm going to use red here. I'm going to take the log, I'll use log, of both sides. So I'm going to take the log of the left, and I'm going to take the log of the right. I would do this in your notes if I were you. Okay, for example, let's suppose I had something like, I'll just use numbers. 10 equals 10. Does the log of 10 equal the log of 10? Yes. 4 equals 4. Does the log of 4 equal the log of 4? Yes. Your left side still equals your right side. So as long as you take the log of everything on the left side and everything on the right side, it's a legal maneuver. Not a problem. Anybody know what's going to happen next? Anybody know? You need the law to do what's next. Amma? Yeah, we're going to use the power law and get that x out front. Right? That was the power law. And look, now, aren't you out to isolate your variable? Let me make this green here. What do you do with things multiplied times a variable? You can multiply by the reciprocal or do the shortcut. How about if I divide the left by log 7 and I divide the right by log 7? Notice where I ended up. Exact same place. Again, I used log instead of ln. You can do the exact same thing with natural log. Probably should have used ln, being I used ln there. Doesn't matter. Natural log of both sides, log of both sides. You end up in the exact same spot. But for something like this, it's a simplistic equation. It's a whole lot easier. Just change it to logarithm form. All right, try D. Try D. Just change it to log form and solve. We'll deal more with this methodology of C on Monday when we solve log equations. Because you only need to do that on the more complicated ones. Oops, I'm stuck in yellow land. Who's got an answer? What do you got, Joe? Anybody agree with Joe? 8.4004? Okay, not hard, right? These aren't hard. Just got to keep straight, keep track of things. Again, you do have to be able to convert from exponent form to log form. And then, the change of base form is really easy. Really, really easy. This is on top of that. So top and bottom, I mean, what could be easier? All right, go ahead and try E. Again, just change it to a logarithm and use the change of base formula. Change it to a logarithm, use the change of base formula. It's best if you can do everything in your calculator. That would be best, instead of getting an intermediate answer and then doing something else to it. You don't want to round off until the end is what I'm trying to tell you. If you can, Try to hold off so you don't round off until the end. Don't you agree with that? Okay. I mean, or the better form really is like that, but either way, it's the same thing. Right? Multiply by the reciprocal instead of having a fraction divided by a fraction, or you can just do the fraction divided by a fraction. Just got to make sure you equal everything out before you divide by that last two. In your calculator, make sure you hit enter or total before you divide by the last two. Or if you do it this way, again, I would use a parentheses right there if you're doing it that way. So again, it could look like that, or it could look like that. Either way. Just make sure in the first one you use a parentheses for your denominator, and the second one you use you total it out before you hit divide by 2. And I don't know how your calculators like doing a 2. I think you got to use another parentheses, right? Because you got to hit your natural log button first. Wait, do you do it first? Yeah, you do it first. You're probably okay. So you can probably do 2 natural log 3 in your calculator. Probably not a problem. Grace, in yours, you got to do 2 probably parentheses, 3 natural log button, close parentheses, and then close parentheses again. Yours, it's easier doing it this way. 2 natural log divided by 3 natural log divided by 2. All right, what do we get here? Who's got an answer? Alexandra, what do you got? 0.3155, right? Is what x is, right? How many able to get that? Okay. Not hard, right? Not hard. And look, 3 to the first power would be 3. So we got to get this thing below a 1. And you got to multiply that 2 times a 0.3 to get it to be 0.6 something. And that's going to work. All right, finish out the last one then. Again, just change it to a logarithm. Use the change of base formula. Change it to a logarithm. And use the change of base formula. Change to a logarithm. Change of base formula. Marissa, what do you got? 8.8614. I agree. Hopefully you do as well. Right? Just like everything we already know how to do, things added to the variable, you move by adding their opposite. So it's going to end up the logarithm of 20 divided by the logarithm of, oh, I never put my 5 there, of 5. And then add a positive 7 to both sides, and that's x, right? No problem, right? Piece of cake. We can do that. Any questions over anything? Any questions over anything? Anybody? Any questions?